Hello, everyone. Welcome to the October Recreational Astronomy Night Meeting, online edition of the Toronto Centre, RASC. Thank you for joining us this evening. My name is Paul Markov, and aside from introducing the speakers, I also search for presentations for upcoming meetings. So if you have a presentation in mind, please get in touch with me. We have openings for the November and later meetings. Before we get started with the presentations, I'd like to thank in advance our technical team comprised of Andrew and Betty Reed, Blake Nancaro, Ward LeGros, and Enya Cholucci. Thank you for making these online presentations possible. We have 3 speakers this evening, and we expect to be done around 9:30. And there has been a change to one of the presentations. Wayne Parker had an urgent matter come up this evening and won't be able to present tonight, but hopefully we'll be able to get him for the November Recreational Astronomy Night meeting. Let me tell you who's going to be talking tonight. Our first speaker is going to be Arnold Brody presenting The Sky This Month, followed by Michael Watson. The title of his presentation is Physically Distanced Astrophotography During a Pandemic. And Claudio Oriani is stepping in this evening. Thank you so much, Claudio, for bailing us out. And he'll talk to us about planetary image processing. And then finally, our president, Ralph Chu, will close the meeting with a few announcements as usual. If you have any questions for our presenters, you can enter them in the YouTube chat box. And Ennio will ask your questions to a speaker on your behalf. And also, if you are attending a meeting for the first time, please let us know through the YouTube chat as well. So let's get started with the meeting. Arnold, over to you with The Sky This Month.
Well, thank you, Paul, and hi, everyone. For The Sky This Month, I'll be covering the period from tonight until November the 10th. And with Mars reaching opposition last night, I thought it would be interesting to take a look at some Mars space missions. And as for observing, we'll take a solar system tour and a look at some Halloween targets. Now, other than Earth, Mars is by far the planet we Earthlings have studied the most. To date, we have launched 62 missions to Mars, with about half or 53% of them either successful, still operating, or on their way. And here's a quick review of some of the Mars missions still operating. First is the Mars Odyssey orbiter that began sending back thermal and spectrographic images since it entered into Martian orbit 21 years ago this month. It's still active, and Odyssey has enough fuel for another 5 years. Mars Express performs high-level resolution imaging and mineralogical mapping of the surface, and also radar sounding of the subsurface structure down to the permafrost, and precise determination of the atmospheric circulation and composition. It has enough fuel to operate till 2026. And for the last 14 years, MRO has been sending back data on the geology and climate of Mars and searching for future landing sites and relaying data from surface missions back to Earth. And NASA intends to continue this one through the late 2020s. And the successful Curiosity rover has a laser for zapping rocks for spectrographic analysis. It has a drill for extracting rock powder for analysis through onboard labs. And it's investigating the Martian climate and geology for helping us assess whether the site inside Gale Crater ever offered conditions favorable for microbial life. And the rover's 2-year mission has been extended indefinitely. Its plutonium power supply can probably last for another dozen years. India's Mars Orbiter mission, or MOM, is a demonstration project to develop the technologies for designing, planning, managing, and operating an interplanetary mission. And MOM carries 5 scientific instruments for studying the morphology, topography, and mineralogy of the Mars surface, and the constituency and dynamics of its atmosphere. And it's got 13 kilograms of fuel left after reaching Mars orbit. It had 40, so it's still using it, and it's got a little bit left, so it may run for a few more years. Now, MAVEN was developed by NASA to investigate the upper atmosphere and ionosphere of Mars and how the solar wind strips compounds from this atmosphere. And this research gives insight into how the planet's climate has changed over time, and it has enough fuel to last until 2030, maybe longer. And a key goal of TGO is to gain a better understanding of methane and other trace gases that could be signs of microbial life or other biological activity. And a lander called Schiaparelli was deployed from TGO 3 days before entering Mars orbit, but it crash landed at over 500 kilometers an hour. And like other orbiters, TGO will also operate as a communications link for Mars rovers and landers. And it has a 7-year planned mission. And InSight is a robotic lander designed to study the deep interior of Mars. Most of its scientific instruments were built by European agencies. InSight is studying the size, thickness, density, and overall structure of Mars's core, mantle, and crust, as well as the rate at which heat escapes from the planet's interior. It has a seismic sensor that can interpret stratification of the interior through any Mars quakes, including meteor strikes or airbursts. Its initial mission is 24 months long, and it has another month to go. It's powered by 2 circular solar arrays, so potentially it could be extended. And here's what's en route to Mars. HOPE is an orbiter from the United Arab Emirates, their first interplanetary mission with a lot of international support. And the name HOPE is not an acronym. It's chosen as a wish for the future of the region as it transitions from a petroleum-based economy to one focused on technology and information. The orbiter was constructed at the University of Colorado, Boulder, with UAE scientists and engineers working with the university's Laboratory for Atmospheric and Space Physics. The University of Arizona and University of California, Berkeley also helped. A Ukrainian transport plane ferried the completed spacecraft from Colorado to Dubai for testing, and then to Japan for launch atop a Mitsubishi Heavy Industries rocket. And scientifically, the probe will study the lower atmosphere of Mars to fill in gaps from the MAVEN mission and help paint a complete picture of Mars's atmosphere's escape into space. And China is sending an orbiter and rover combined in their Tianwen-1 mission. Between them, they intend to look for evidence of current or past life, produce Martian surface maps, characterize the Martian soil composition and water ice distribution, as well as examine the Martian atmosphere and ionosphere. And it also deployed a third component, a selfie camera, to take a picture of itself while in transit. Here's that picture. It had a lot of international support. Argentina helped track the spacecraft, and France helped with the rover's laser spectroscopy system. Australia contributed to the orbiter's magnetic mapping system and helped calibrate the instruments. NASA's Perseverance rover carries 7 scientific instruments to study the Martian surface at Jezero Crater. It will analyze surface materials, use ground-penetrating radar, measure wind speed, direction, pressure, temperature, test their ability to extract oxygen from CO2 for rocket fuel or life support, and detect organic compounds with fine-scale imaging and ultraviolet lasers. It will also cache samples for a future mission to pick them up and return to Earth. And its plutonium power supply will last probably 14 years. And the Ingenuity helicopter seen on the right, that's a demonstration project to see if a small helicopter can help a rover by scouting for suitable targets and choosing a path for navigating to them. It carries a downward-facing camera and is expected to fly 90 seconds before needing to settle down for a recharge. As for future Mars missions, back in 2016, Elon Musk said that SpaceX would attempt a cargo to Mars demo in 2022 and a cargo and crew mission to Mars 2 years after that. The vehicle for getting there would be Starship, currently under development at a SpaceX facility in Boca Chica, Texas. Development of Starship is progressing in fits and starts, so it really remains to be seen if SpaceX can actually send a Starship to Mars in just 2 years. The first prototype of the spaceship is seen on the left, and on the right is an image of what a future colony on Mars might look like. Now, with the spacecraft stacked on top of the booster stage, it'll stand 120 meters tall, which will make it the largest rocket to date. And construction has begun on the first booster stage. And it will have a payload volume bigger than the James Webb Telescope, and will also be designed for in-flight refueling from another Starship refueling vessel, so that you can go on international, I should say interplanetary flights. And in the passenger configuration, Starship can carry 100 passengers, a crew of 100. In the cargo configuration, it can lift 150 metric tons into low Earth orbit, and that's 10 metric tons more than the strongest spaceship can do now. And because the entire booster stage and Starship spacecraft itself, they're both totally recyclable, that will reduce the cost of a launch to $2 million, just $2 million. Compare that to $450 million to launch a shuttle 10 years ago. And that facility in Texas will ultimately churn out a complete new Starship every 72 hours. That's the plan. And they also expect to have an operational fleet of 1,000 Starships. Are you interested in maybe sending cargo to Mars? In that case, you're going to want to download the Starship User Guide. Now, this morning, 2 Russian cosmonauts and an astronaut took off for the ISS and arrived there only 3 hours later on a very quick trip up to the ISS. And at the end of this month, there will be 4 more going up in the SpaceX Dragon. That's at the end of October. And this will mark the beginning of 7-member expeditions at the ISS. And now we're on to observing. For us in southern Ontario, the sky is as dark as it can be for about 9 3/4 hours tonight, and nearly 10 hours by this time next month, or 11 hours. Visual astronomers, you can enjoy an extra hour of observing by including astronomical twilight and dawn, when it's definitely dark enough to enjoy the solar system targets, for example. Daylight savings, that time ends at 2 a.m. Sunday, November 1, and here are the times of sunset for us in southern Ontario on November 1 and 2. And you may have heard there is a bill before the Ontario legislature to do away with these time shifts and simply use daylight savings as the one time we will use all year round, provided Quebec and New York State follow suit. Who knows, it might not be too far from now when we don't do clock changes anymore. Now, auroras. Years of research show that there is an increase in aurora activity when the Earth's magnetic poles lie perpendicular to the solar wind at the equinoxes, producing what's called equinox cracks, which the solar wind can pour through for hours and excite the upper atmosphere. The cracks are the result of south-facing or south-moving solar wind elements brushing up against the northward traveling Earth's magnetic field, and where they touch, they cancel each other out, opening a hole that the radiation can pour through. A study of a history of study, excuse me, I'm stuck there. A study of auroras in the past 57 years show that September and October are 2 of the most active months of the year for solar geomagnetic storms and auroras. And if you would like to get an alert about auroras that may be happening now that we are in that active period, and now that solar cycle 25 is ramping up, you can go to the website shown on this slide and sign up for the alerts. As I've done here, I've signed up for advisories, and as a result, I get an email once a week, such as the one on the right, and it will let me know if there's any solar activity, geomagnetic activity that may produce auroras. Another solar effect is a zodiacal light, which is easily seen in the fall in the east before sunrise when the ecliptic is quite vertical. And I got a image here lifted from Stellarium, and I'm not sure how well it can show the zodiacal light. So there's an image in the upper left corner taken in 2012 of exactly this scenario when Venus happened to be in the same position as it is now. Now on to the moon. We're in the dark stretch of October right now with the new moon just a couple of days away. It will actually be a super new moon occurring at perigee, and that should create some interesting tides. And next week, the moon sets just after midnight, Tuesday night into Wednesday, so it will not interfere with the Orionids peaking that night. At nightfall on the 22nd, the moon makes a tight triangle with Jupiter and Saturn and comes close to Mars the following Thursday. The falling leaves moon, or the hunter's moon, is on Halloween night, Saturday, October the 31st. It's just after apogee and will be the smallest micromoon of the year. And it's also the second full moon in October. Some people refer to that as the blue moon, the second full moon in a month. The older definition is the third full moon in a season with 4. If you follow that definition, it won't be until November's full moon. But that's just a name. It doesn't really matter. And dark skies will return to us in the second week of November. Now, when the moon is one day past first quarter, there's an opportunity to see Rupus Recta, commonly called the Straight Wall. It's a linear fault on the eastern edge of Mare Nubium, about a third of the way down the southern hemisphere, and slightly left of center. Now, when 8 days past new, sunrise is occurring along the terminator, and the cliff face stands out in shadow, as seen on the left. The fault is very nearly straight and runs for 110 kilometers, and is estimated to be around 300 meters higher on the east side, 300 meters, with a slope of 2.5 kilometers wide. And to its west is Burt Crater, 17 kilometers wide, and to the northeast of that crater is Rima Burt. It's a slightly curved 50-kilometer long channel, and it could be a former lava tube whose roof collapsed, exposing a half-pipe. Its northern end comes down a mound, suggesting a lava dome, and this in volcanic interpretation. So this particular area on the moon is definitely an interesting one to study for its geological history when the sun is in the right position. On the right, we see the sun setting. This is the terminator as the sun is setting in that region. And at that point, the sun is brilliantly lighting up the cliff face of Rupa Recta. And it makes it look like a sword. There's a curved mountain at the bottom, what's left of a flooded crater that looks like a sword handle guard, with the cliff being the sword. There are 2 lunar occultations of magnitude 4 stars this month. The first occurs on Saturday, October 24, with a waxing moon covering Epsilon Capricorni around 9:12 p.m. and 1 week later with a full moon occulting Xi 1 Ceti just after midnight Friday into Saturday. By the way, that star is a double, so you might see it wink out in steps. And now for the rest of our solar system. Here we see a lineup of the 5 superior planets, dwarf planets Pluto and Ceres, and comet 88P Howell on the far right, as of 8 p.m. tomorrow night. Only Mercury and Venus are missing. And Venus will rise around 4:15 the next morning, so if you want to observe these objects as soon as nightfall, you can observe all of the objects seen here as soon as it gets dark. You don't have to wait. And then grab some sleep and come back out at 5 in the morning, and you can catch Venus as it has risen. If you want to also include Mercury, you're going to have to wait until November. There's a great chance to see Mercury in the morning on November the 10th. I'll talk about that in a couple of slides. You might also see some meteors across the sky. That's because we have 4 showers concurrently running at this time. And so let's start our tour as we would when observing, by starting with the targets that'll set first. and work our way west to east. So we'll start now with 88P Howell. This comet was photographed. Here we see an image taken 1 month ago by Jose Chambo Brice in Spain. And this is the comet's position as of Friday night, west of the Teapot Spout. It was estimated to be at magnitude 9 early in October. The comet passed perihelion on September 2 and is fading now as Earth's orbit is pulling us away from the comet. It should be possible to see it in a small telescope, maybe 8 inches or so, because it's going to be fairly low in the sky, and we're going to need some really good seeing to catch it. So maybe an 8-inch might be adequate to see this comet. And it's running across the top of the Teapot Spout right now, and it'll go through the dome of the teapot and then clip the handle in the first week of November. The comet's 5.5-year elliptical orbit brings it as close to the Sun as Mars and as far away as Jupiter, and its orbit aligns very closely with the ecliptic. The comet was discovered in 1981 by Helen Howell while studying photographic plates for supernovae. Those plates were produced with the Palomar Observatory's 46-centimeter Schmidt telescope, which is now retired. Next up is Jupiter. Jupiter is saying its goodbye after having hung out with us all summer, but it's still quite bright at negative 2.25 tonight and 39 arcseconds wide, but it will be dimming a bit by November 10 and shrinking to 36 arcseconds. But you can easily spot this planet, of course, it's so bright, drifting in the eastern side of Sagittarius, inching ever closer to Saturn. By November 10, the two planets will appear 4¼ degrees apart. Colored filters for planetary observing can really help enhance certain features. For example, a blue filter on Jupiter will darken the orangish equatorial belts and the great red spot. It'll make them darker and easier to spot. And if you like to watch Jupiter's moons, here's a fun one for you. At 8:30 on the evening of Sunday, November 1, you can watch Io exit from Jupiter's shadow while Ganymede's shadow is transiting Jupiter. And keep an eye on that little circle. There's Io popping back out. And you can look up Jupiter moon events in the Observer's Handbook or at the websites shown here. Moving east, Pluto is the next solar system object. Under ideal conditions, a 10-inch telescope should be able to see down to magnitude 14.7, making it possible to glimpse Pluto. The image here from Starry Night Pro has the field flipped right to left to match the view in an SCT with a star diagonal, with stars down to magnitude 14.6, slightly dimmer than Pluto at 14.4. So good luck if you want to try. On to Saturn. Saturn is also east of the Teapot, drifting slightly eastward over the next 4 weeks. The rings are tilted near their max, showing us their northern face, and they double the overall angular size of the target they are twice as wide. They will double the overall effect of looking at Saturn. Instead of the 17 arcseconds shown in the chart, the overall effect is larger. And Titan is usually easy to spot. If you have a large telescope, you might also pick out some of Saturn's other moons, the faint dots you see here near the planet: Rhea, Dione, Enceladus, and Tethys, and Iapetus just outside Titan's orbit. The cloud bands on Saturn are subtle. A yellow filter can help darken them a bit and make them somewhat easier to see. The dwarf planet and asteroid Ceres passed opposition 6 weeks ago. Its apparent magnitude sits at 7.56, so any size binoculars or telescope can spot it. Here's an 8 arc-minute wide inverted view centered on Ceres. It's in a star-poor area with only 3 brighter than magnitude 14 visible around Ceres. In other words, Ceres will be the brightest dot in that area, making it easy to identify. From Ceres, it's a jump of 23 1/3 degrees northeast to arrive at Neptune. Use Phi Aquarii to easily find Neptune. In a rigel finder, put the star partway inside the 2-degree circle around the 230 position, and Neptune should be in your eyepiece. And here's what the view looks through a Telrad site. And here's a close-up, inverted, inside an 8 arc-minute wide field of view. Neptune is the blue circle in the center with Triton, the small dot, beside it. And to the upper left is an 8.7 magnitude star. Now, Neptune can be seen in binoculars or telescope and is easy to recognize by its blue color. But you'll need a 12-inch telescope to spot its moon, Triton, that orbits Neptune backwards, east to west. In fact, Triton's orbit is degrading and is expected to get so close to Neptune in about 100 million years that Neptune's gravity will rip it apart into a ring. And now we come to Mars, which reached opposition at 7:18 last night and is probably as good as it gets for observing for us here in southern Ontario right now. Now, Mars was closer in August of 2003 when its angular size was 25 arc seconds compared to 23 arc seconds at closest approach a week ago. But back in August 2003, Mars was only 30 degrees high at its highest, which means we were looking through 2 atmospheres to try and study its details. This time, however, Mars is much higher. It's 51 degrees up, so that we're only looking through 1.3 air masses. So we're now looking through quite as much murk. We should probably get steadier air and greater opportunities to observe its detail. So what we lose, those 2 arc seconds in angular size compared to 2003, in my estimation, we more than make up for it with Mars 21 degrees higher in the sky. Notice how rapidly Mars drops in magnitude and angular size by November the 10th. So don't delay. As we pass Mars in our smaller orbit, Mars is continuing in its retrograde motion. As for the details we can hope to see on the surface of Mars, if you haven't already, please have a look at Chris Vaughn's presentation last month, in which he highlights the major Martian features. With Mars so close right now, it should be possible with a 10-inch or larger telescope to spot the tiny moons of Mars, Phobos, 22.2 kilometers wide, and Deimos, 12.6 kilometers. They orbit Mars rapidly. Deimos takes 30.35 hours to circle Mars, and Phobos only needs 7.66 hours. So they do travel around Mars significantly over the course of one evening. This chart, showing the positions of the 2 moons over time, was generated by Martian Moon Tracker using time parameters that I input. Now, the trick to seeing Phobos and Deimos is to catch them when furthest from the glare of Mars. Over the next 5 days that are shown in this chart, there appears to be a good opportunity around 8 p.m. Eastern Daylight Time this coming Saturday, when those 2 moons will be as far from the planet as they can get. An orange filter will bring out the dark landforms, and a blue filter will help bring out the polar cap and white or blue limb haze on Mars. And if you're up before dawn, you can catch Venus as it continues its plunge down behind the sun. At 6 o'clock tomorrow morning, Venus will be 18 degrees high with astronomical dawn just beginning. Venus will be gibbous, 76% illuminated, and still brilliant at -4 magnitude. But seeing its phase in a telescope can be a challenge due to the planet's glare. As the sky brightens, however, the contrast between Venus and the sky lessens, and that cuts the glare, making the phase easier to see. And you can also try a neutral density filter or a moon filter to cut the glare. Our best chance to see elusive Mercury is before dawn in the east on November 10. And that's the date of Mercury's greatest western elongation from the sun, when it rises as far in advance of the sun as possible. And with the ecliptic fairly steep in fall mornings, this helps Mercury climb high ahead of the sun, At 6 a.m. on November 10, Mercury is already 7 degrees up as shown here, and it will reach 11 degrees by 6:30 with the sun still 6 degrees down. This should give you a good opportunity to hopefully catch a glimpse of Mercury's half-lit phase. But give it up after 6:45 or so as the sun is getting dangerously close to rising. And there are 4 meteor showers currently happening, working our way clockwise in this diagram, starting with the Andromedids. The parent body for that shower no longer exists. It broke up in the 1840s. And the zenith hourly rate for that meteor shower has dropped to only about 3 over the last century, but there is expectation of a future increase as Earth approaches one of the 2 patches of debris left over from the breakup. The northern and southern torids overlap in their timings, which is not surprising since they have a common ancestry. The southern component's parent is Comet 2P Encke. The northern torid's parent is asteroid 2004 TG10, which is believed to be a fragment from Comet Encke. Both have a ZHR of 5, we'll call it 10 together. And saving the best for last, the Ornids are currently showering and are expected to peak a week from tonight with a ZHR of 20. And with a number of showers running concurrently, you do stand a good chance of seeing one if you lie back and look up for a period of time. These showers sometimes produce fireballs. There were 2 fireballs reported to the IMO just last week, one over South America and one over France. The IMO is the International Meteor Organization, and they encourage public reports on fireballs as well as submissions on meteor shower observations. So it's an easy and a fun way to engage in citizen science without having to make a huge investment in expensive gear. You can visit their website to learn more, join, and contribute. And now it's time for Halloween in space.
And it's a graveyard.
And what could be better for Halloween than a full moon? This Halloween features a full moon on a Saturday night with kids running around in costumes high as kites on sugar. And then there are the adults. Scary stuff. But contrary to popular belief, you can observe the full moon. Just use a moon filter to cut the brightness down. Most moon filters reduce transmission by 87%. That makes it much easier to observe the moon and study its details. You can do geology, looking for the darker areas containing iron, titanium, and other dark metals that tend to sink towards the center of a forming body. So seeing them on the surface would help explain their volcanic journey as they rose up as lava through cracks from huge asteroid hits. The brighter highlands to the south are rich in anorthosite rocks containing aluminum, and you can find volcanic ash deposits during full moon, such as the 3 dark patches found on the floor of Alphonsus crater. Since the sun is overhead there are no shadows, so the dark areas you can see are ash deposits, not shadows. And it's easy to trace the bright rays of ejected material from Tycho. In fact, if you study the moon, you can find other craters with bright rays. Those bright rays indicate that the craters are fairly fresh because over time, cosmic rays, space weathering, and micrometeor hits will remove those rays. Are you old enough to remember E.T. sneaking out on Halloween in a plot to call home? Well, as you may know, he's found a home in space. We call it NGC 457. That cluster is found just 2 degrees southeast of Rukba, or Delta Cassiopeiae. It's a rich cluster with over 150 stars, with a noticeable concentration, a large range of brightness, and the cluster is around 7,900 light years from us, and it's quite young at only 21 million years old. And our final Halloween target is the Witch Nebula, IC 2118, a reflection nebula in the constellation Eridanus, west of Orion. The dust grains of the cloud are illuminated by nearby brilliant Rigel. Rigel shines 120,000 times brighter than our sun, which is how it's able to illuminate this cloud lying 40 astronomical units away from it. Now that's 40 times the Earth-Sun distance, or the radius of Pluto's orbit. Conditions in the nebula are favorable for star formation. Astronomers have detected candidates for pre-main sequence stars. They are found well within the Witch's Head, so there are stars forming inside the Witch Head Nebula. The location of the Witch Head Nebula is easy to find. It's a little over 2.5 degrees west-northwest of Rigel, and it's a large object. It really measures more than 4 degrees in length, and that stretches its magnitude of 8 down to a surface brightness of 17.82, and that is faint. To visually see it, you need the darkest location you can get to, no moon, and above average transparency. Now, 4 or 5 inch refractors are capable of showing it, according to a discussion I read on the Cloudy Nights forum. One fellow said he saw it in a 101 millimeter teleview refractor and a 35 millimeter panopic eyepiece, and that would provide 15 times magnification and a 4.4 field of view. The bigger your telescope aperture, the better your chances, of course, though they will provide you with a smaller field of view, so you may need to sweep along the nebula's length to see all of it. And that wraps it up. Thank you and have a happy Halloween.
All right. Thank you so much, Arnold. That was a very comprehensive and thorough presentation on the sky this month. Let's move on to some questions. Anya, do we have any?
Well, I do have a question right off the bat. For the Orionoids meteor shower, is it possible to see any within the city, or is it really mandatory to get out of the city to see any?
It's mandatory. Generally speaking, it's a good idea to get out of the city to see meteors. Many of them may be very faint, and you would not be able to see it with any kind of sky glow, so you really want a dark sky. You really want to pick a night with no moon. If you have an opportunity to get out of the city, that might help. But if you can't, you can always cross your finger for a fireball. Fireballs are so bright they can light up the sky as bright as daytime. So that would be maybe your best chance, as if there is, maybe not necessarily a fireball, but there might be a few that are brighter than average. You might catch 1 or 2 that are really bright. But basically, if you can, do try and get out of town.
We have another question that's come in. What capable binoculars are recommended to view Jupiter and Saturn for this year? And also Mars, of course.
It's commonly suggested that 10 by 50 binoculars are what you would want for astronomy purposes. Now, if you happen to have a different size pair of binoculars in your closet, go ahead and use it. They will definitely show you a lot more than you can with your eyes alone. But if you are in the market for binoculars, you might want to get a pair that are 10 by 50 or 7 by 50. The second number 50 is the size of the lenses up front, and that's 2 inches. And that brings in a lot of light. They're not too heavy at that size either. More popular lately are Poro prism binoculars. They are smaller and lighter weight. You can get them in similar dimensions, like 7 by 48, numbers like that.
Okay, so sounds like we don't have any other questions. We'll move on to our next speaker. Thanks again, Arnold, for your presentation. Much appreciated.
Take care.
All right, very good. So our next speaker is Michael Watson about socially distant imaging, I guess. Over to you, Michael.
First of all, let me just check to make sure I can be heard. If someone could just tell me yes or no. Yes. Okay. Great. Well, hello everybody, and good evening. Middle of October, as we get to the end of summer, it's great to be back at a Toronto Centre meeting, and thank you, Paul, for inviting me to speak about my favorite passion, as many of you will know, which is astrophotography. In this most unusual of years, I can say. And when Paul was asking what I might talk about, I decided that the appropriate subject would be this: physically distanced astrophotography during a pandemic. Now, you might think, well, duh, because any serious astrophotography is physically distanced, particularly if you're doing deep sky work and you have to get out of the city, as I do. I think it's fair to say that serious astrophotographers aren't very close to other astronomers when they're doing their work. So this is just, as I say here, a little bit tongue-in-cheek. This year has been it's been an interesting year in a whole bunch of ways. But for astronomy in particular, we've in the early part of the pandemic, following the middle of March, everybody was advised not to, to stay indoors, not to go out of the city, and in Ontario, certainly all of our provincial parks were closed. I'll tell you a little story that in, I think it was early April, I went up one nice new moon, dark night evening in the middle of the week to Torrance Barrens, which is, of course, a dark sky preserve, where I'd gone on in many previous years. I don't go there much any longer because, frankly, it's getting a little bit too bright. I couldn't believe it when I got there. It wasn't that there were astronomers there. There were partiers there. It was unbelievable. Hundreds of cars. And I managed to find a little spot that I thought would be okay, managed to get all of my gear set up, which takes about 3/4 of an hour. Then the OPP came in, the provincial police, and said, everybody has to leave. The park is closed at night. Well, that's kind of, Mr. Officer, when I go out. You got to leave too. So another half hour to take down the equipment, drive back to Toronto, and that was it. However, later on, the parks did reopen, and went up to my favorite spot, which is Algonquin, as many of you who follow my astrophotos know, Algonquin Park. And what was really interesting in the few times that I've been there this summer is certainly in June and July and August, well, June and July primarily, there was hardly any road traffic, and it was incredibly quiet. The offices were closed. The students who come in from around the globe to work at the park were completely absent. It was very quiet, which was fantastic, but just a little bit strange. And then, of course, things have opened up recently. So I managed to get out a little bit, and I just thought that what I would do is show you just a few photos that I've managed to get over the pandemic months. And I have to say that only about half of them I've managed to process so far. So this is from May, actually back into April until this morning, and I'll finish up with that. So I thought that what I would do is start with the easy stuff that you can shoot from the city using just a tripod and camera. And I, in addition to sort of really good technical photographs, those of you who follow me know that I like to do pictorial astrophotos as well. And so an example is this. I really like shooting the moon during the daytime. You can get subtle gradations that you can't of both color and brightness that you really can't get quite as much at night. And if there is a scudding cloud across the sky, you can make what I think is a really nice photo such as this. Was taken with a 400mm lens, short exposure on a tripod, and that can be really a lot of fun. This was back in April. Oh dear. Well, I don't know why. Why would that be? Let me just check here. Okay, can you see that? Okay, everybody. Oh, so sorry. All right, something went wrong there. Okay, well, this is the first one. So this is what I was talking about, 400 millimeter lens photo of the waxing gibbous moon. And so we move on here, and this shows, again, I really do like shooting the moon during the day. It's a very different view. It's you don't often see a photograph like this with a blue background, and I'm going to tell you that these are not enhanced colors. This is what it looks like, obviously with a little bit of contrast added in processing, and then just turning it around so as to make it a slightly bigger picture on the same afternoon. You can get an awful lot of detail here. And down in this corner, I hope that that you can see my cursor. You can see in these two particular Maria, and it's really interesting, if you do a little bit of color saturation, there are very different colors and shadings here. This part tends to be much bluer, and this part slightly yellower, particularly when you're photographing at night. And I found that actually to be really, really interesting. So the moon is always fun to shoot. And then back in April, the almost full moon. And I think you can actually see it a little bit more here. You see what it's a slate gray with maybe just a slight bit of blue, and then a more yellow tinge there, which I interpret as being a different age and possibly composition of the lava flows that produce the Maria. So there's the waxing gibbous moon. This is one of my favorite shots recently. This was right at the end of April. Managed to get a really nice, clear, and steady, more than clear even, night to, or sort of early mid-twilight to photograph the waxing crescent moon. And another view of this as well. Earthshine is one of my favorite things. It can be tricky to photograph, but with some careful work and some post-processing, you can show some really good earthshine with even with a fairly fat crescent moon here. This is taken through 152 millimeter or 6-inch diameter refracting telescope, and this happened to be in quite a rich star field, and I really like views like this. We got a good one actually this morning with Venus. You'll see just one photograph of that at the end of the presentation. This one I really like. This is really just a pictorial one, taken handheld with a 400 millimeter lens up at our family cottage in Muskoka, and it was actually on Independence Day, Tom Cruise Day, July 4th, and the full moon was rising in the southeast, of course, because the full moon in the summer is very low in the sky. And I'm going to tell you that was the color. A lot of people see that photograph and wonder, well, you must have enhanced it. No, that was the color. And I attribute that to, well, first of all, very low altitude. But second, also, I think that by that time, some of the dust particles, well, smoke particles, the particulate matter from the fires on the North American West Coast had managed to pass into Ontario and the eastern part of North America. And that particulate matter was turning the sky a little bit orange. And I noticed that as well in doing some astrophotography in August, which we'll talk about. Right, everybody. I guess we had a little bit of a technical glitch, and I'm not sure where I left off, but in case you didn't hear it, I attribute this real orange, and this is exactly how it looked to the unaided eye and also in binoculars, to particulate matter that had blown eastward to eastern North America from the fires that we all know were burning in California and the Pacific Northwest. So this was quite a remarkable sight to me. It was very interesting. Okay, now. So Venus, we know that Venus has been very prominent in the sky. First of all, in the evening sky, earlier in the spring, and then now in the morning sky. This is one of the great years to see Venus. We get this apparition almost exactly the same way every 8 years. And so I think that we all know from this graphic that Venus passed very close to Aldebaran and was passing through Taurus and very close to the Pleiades with what happened to be very good weather for people in Ontario in April. And so managed to get a photograph here. This is taken through the telescope, and this is right from our parking pad in Midtown Toronto. And so the stars won't necessarily be immediately obvious to you, but this, of course, is the Pleiades. And there we have Venus very close, really bright, about as bright as you can get at magnitude minus 4.6, with really close to the Pleiades. And you don't get that very often. It's going to be years before we get that again. Venus was passing through the Pleiades, and we had a couple of cloudy nights, but then just a little bit later, 3 days later, it had moved past the Pleiades, and we see the Pleiades there on the right. This is with a shorter focal length telescope, about 540 millimeters instead of 660 millimeters. And by the way, I think that there have been discussion. Blake had talked about, Arnold had talked about the about teleview refractors. Those are the ones that I use for this kind of work. And this was just such a great view, and something that you can see from and photograph from the city using a fairly modest equatorial mount and a fairly decent telescope. So that was Venus passing by. And then, and I'm not going to pretend that this is a good photograph at all. However, I shot this with my 152 millimeter 6-inch refractor that has a focal length of about 1250 millimeters. This is incredibly cropped. This is the crescent of Venus, just one very short photo. So no one's going to pretend that this is a great photo. I'll liken it to what Galileo saw 400 years ago, but it does show that you can get something that's kind of interesting to see. Even with a short focal length telescope. Then we have, of course, the Moon and Venus moving into the morning sky after July, and back in August, the waning crescent moon, with a fairly fat crescent there and visible Earthshine, was passed quite close to Venus, and so this was the middle of August. I really, I did like this. It was really very pretty to see, just gorgeous naked eye and binoculars. This is a 200 millimeter lens. And then going in a little closer that same evening, we can see this with the moon, a bunch of stars, and Venus. Now, this is this morning. So I got up early a couple of times just to check. It was clear. This is from our back deck again in Midtown Toronto. And this was the view with brilliant Venus this morning. Really nice view. I just really like this an awful lot. So this is really easy to do pictorial astrophotography. And I will say that I was physically distanced from my wife because she was still in bed. And there I was out in the gathering morning twilight photographing this. Okay, so we know that this was the summer of the best comet we have had in probably a generation. This was, it was difficult to see early on. This was in late, I think it was late May, and I'd gone out in a couple of evenings. This is actually from Toronto, from Midtown Toronto. I'd gone out to a schoolyard and had tried to find the darn thing, managed to sweep it up barely in binoculars, and thought, well, listen, why not try with a 200 millimeter lens? And I was actually quite shocked to get any tail. But I did, from the city, and so that was kind of fun to get. And I was hoping then that we would have a decent view of this, but I knew that in order to get anything at all, I'd have to get out of the city. And when I got this photograph, the parks had not yet opened, so I couldn't get up to Algonquin. But very shortly after that, they did, as I say. And so I got up to Algonquin, and here I am set up, and this is May, as you can see. Set up with my astrophysics mount, and I've got two telescopes mounted side by side here. Some of you have seen these pictures before. The sort of black, gray one is an Explore Scientific triplet refractor in a carbon fiber tube. That's the one that I do my moon photos in. And then the TeleVue refractor, which is beside it, which is what I do most of my decent, I won't put it any higher than that, deep sky photos. And by the way, if you take a look at, if you see the red mounting rings, it's very difficult to find really good mounting rings and plates that will fit telescopes, and that came from, I ordered from an Italian company, and managed to get them here and there. It's an unbelievably beautiful equipment. So that's the stuff I use. You'll see two Kendrick batteries down there at the bottom. I use two of them, one to run the telescope drive and the other to run the dew heaters. Okay, moving on. So this is one of the photos that I managed to get the first evening up in Algonquin. This is taken with a 200 millimeter lens mounted piggyback on the telescope. And I was really pleased. I'm not going to say it's the greatest photograph. It's not. It's grainy and so on, but it was low in the sky, almost due north in Ursa Major. But I was very pleased to be able to get not only the gold yellow dust tail, but also the blue ion or plasma tail, which you don't necessarily often see with comets. Not that we get that many, but I was really pleased to get that. And then I shot a closer view with the TeleVue 127 or millimeter or 5-inch diameter telescope. And that is this one. This photograph was above the editorial page or the editorial in one of the recent issues of Sky News magazine. And again, you can see some of the ion tail there. And I should tell you, this photograph was made, you'll find it hard to believe, with a stack of 30-second exposures. That's all, using my Nikon D810A camera that many of you will be familiar with the very typical green head that comets typically show. So here, just some other stuff that I managed to get during the summer. I don't know whether you're going to be able, without lines, to be able to figure out what the heck that is. So this is looking due north, and what do we have here? The bowl of the Dipper on the left, Ursa Minor on the right, and we see the pointer stars that actually don't really point exactly in the direction of Polaris, but here we see Polaris. And you can see here that Polaris is close to, but not really right at the North Celestial Pole. I think all astronomers know that. It's about 52 arc minutes, or about almost, but not quite, 2 moon diameters away from the actual North Pole. And so here we see Ursa Major and Draco and Ursa Minor and Camelot Pardalis. And you can see here that Draco, it's a really interesting constellation, because it really encircles Ursa Minor and the pole star. So I like shooting these, and you can see some M97 and some deep sky objects, M109 over there as well. There's not an awful lot to see in this area, but I like this. Then we move on, and I decided to shoot some stuff because I was there in May when Ursa Major was really really quite prominently displayed. I decided to try to get something through the 6-inch refractor. And these photos are made from 1-minute exposures. And numerous of them that are stacked. But again, it's not a great photo, but you definitely can see some interesting color. And a fair amount of dust and certainly the dust lanes. And so we see here a bunch of various stars all around of magnitudes going down to 12th magnitude here. And yeah, I really like that. And here we see some other much fainter galaxies. So that's M51. Then the Pinwheel Galaxy, M101, which I really like as well. It's fainter, it's larger. I find it a little more difficult to photograph. Obviously I'm not using the best telescope to get something like this. And we see here that a lot of different knots in this galaxy have their own NGC numbers. They are their own deep sky objects, although they are embedded knots in the entire galaxy. And then a 14th magnitude galaxy here, another NGC galaxy, and a 14.9 galaxy over here. So in this area of the sky, there are several galaxies that you can that it's easy to overlook if you're looking just for the main bright one. And I decided to put this together because this shows these two galaxies that aren't very far apart in the sky to exactly the same scale. And you don't get a chance to to sort of imagine that. And so we can see how much bigger the Pinwheel Galaxy M101 is from M51. Okay, moving on. That's another one taken through the Large Telescope. And this is one M106 with a number of galaxies. These were more experimental shots because a refractor is not necessarily the best one to shoot these with. But you can see here in M106, I was a little surprised. You see a lot of dark knots here. And again, these are just 1-minute exposures stacked. Edge-on Galaxy here, which actually looks a little bit like the Sombrero Galaxy, M104. And here you can see, so magnitude 11.7. These are the distances, quite a long way away. And then this tiny little pair, it's really interesting. They look close, but the distance, as you can see, 50 million versus 350 million light years, they're very different. So they're merely line of sight close to each other. And when you're looking at these distances, we bear in mind that the Andromeda Galaxy is about 3 million light years away. So you can see how much further, an order of magnitude, these are than the Andromeda Galaxy. And then moving on, I think everybody knows this. The double cluster doesn't need any kind of introduction. I really like shooting this in the constellation of Perseus, just below in the fall sky, the W of Cassiopeia. These stars really, a lot of them are really blue, meaning young stars and quite hot stars. But there's some orange older ones there as well. This is now I like globular clusters. They are difficult to photograph and photograph well, and this may be one of the most difficult of all. And the reason is that M15 is one. Well, first of all, it's one of the oldest globular clusters known, but it's also incredibly densely packed. I've never seen a photograph that actually resolves M15 right to its core, and I had to do some sort of fancy processing to try to get as many of the stars as close into the core as I could. And I'm going to say that I'm reasonably happy with this. It's small. It's in Pegasus. I really like it. It's really quite easy to spot, but it is small. And for me anyway, I found it a challenge. And this is the best one I've ever been able to make to get of M15. And if we get a clear night, it's right up there because it's a fall object. Although you can see it also, in July and August, but much later in the night. All right, so you can see how ancient it is and how many stars there are. Okay, then moving on, many of you will know that I love shooting my favorite constellation, which is Cygnus the Swan. And here we see, I'll just put this out. Here we see the Northern Cross, well known here with Alberio, and the North American and Pelican nebulae with the great ionized hydrogen clouds around Satyr, Gamma Cygni. Down here, we have the Veil Nebula, the eastern and western parts, and then a little part that's not quite as well known, Pickering's Triangle there. I didn't have time this summer or enough clear nights to do a close-up of that, and all sorts of open clusters. Not many globular clusters in this part of the sky, mainly open clusters indicated by the green here. And then one of the great dark nebulae of the sky, Le Gentil 3. And here, this is the northern coal sack. Anybody who's been in the southern hemisphere knows of the coal sack, which is very close to Crux, the Southern Cross. And here we have the so-called northern coal sack in the Northern Cross. So I really like this part of the sky a lot. And to the right over here, we get down towards Scutum and then Sagittarius, the center of the Milky Way. A little bit closer view here, then we have brilliant Deneb, which is Alpha Cygni, the brightest star in Cygnus, an enormous star. If it were as close as our sun is to us, if its limb were on the horizon, its upper limb would be 60 degrees high. It is enormous and a great distance away. The North American Nebula here, the Pelican Nebula here, and then Satyr or Gamma Cygni. So a close-up of all of the great hydrogen alpha areas. Moving on into what is one of my favorite areas of the sky, Aquila and Scutum, the Shield and Serpens. The Serpent, there are two separate parts to this constellation. And what we get here is a lot of dark globules, a lot of foreground dark nebulae studied intensively by E.E. Barnard in the US, and therefore named for his catalog the B numbers, B102, B112, etc. He made a great study of these, and I love this area of the sky. And this is shot with a camera lens mounted just piggyback on top of the telescope. A little bit closer, this is one of the most interesting Messier objects, M24. Many people think that it's been misnamed, that it wasn't actually a Messier object. It's really just a star cloud, but it's a very bright and prominent star cloud in northern Sagittarius. Quite easy to photograph again. This is the accepted outline of it. It has some open clusters, as these objects tend to, and then a very prominent dark nebula, well known, B92 in this area. And then we get into Scutum, and the best object there, very well known to everybody, M11, the so-called wild duck cluster. And I really do like this a lot. What we often tend to overlook is the dark nebulae that are all around it, because it's such a pretty, sort of, beautiful, gossamer stardust object to look at. And a lot of these are named, as you can see, another pretty little open cluster there. So I really like M11. And I'll say just today, I photographed I processed a closer view in view of M11. And what's really prominent here, and what you can really see, is that it's a young cluster with hot blue and fairly young stars. I'm probably getting fairly close to the end, so I'm going to go through these fairly quickly. Right in Aquila, you get an awful lot of dark nebulae as well. And then just a few. These are always really low in the sky. So we have Antares here, and we have great nebulosity. And I was really surprised. From Ontario, it's really hard actually to get the colors of these nebulae. I happened to get a very dark sky in July to photograph this, and I was just really pleased with that. It's a beautiful area of the sky. Then the Sagittarius, the very well-known Sagittarius clusters of the Omega Nebula here, and M18, the open star cluster. So you can see the open star cluster here. M17 and M18, and very close to the M24 star cloud, with another very large NGC open cluster there. These are well-known objects in the sky, and then the Eagle Nebula. Another view. This is made famous by the famous Hubble telescope photo, the so-called pillars of creation. What you can do with a little telescope to show them, obviously not 1% as well as Hubble did, but there's something. And this is one that I actually just recently processed, showing this as well. You can see the pillars of creation right in here. Again, 1 minute exposures, that's all these are. And then one of my favorite areas of the sky. This is frankly the kind of photograph that I'm able to get in Australia. I never thought I'd be able to get a photo that I think is a pretty good one from Canada. With these objects only about 22 to 24 degrees high in the sky. This was in August, by the way, as well, when they were starting to get a little bit lower in the sky. So I was fairly happy to get this. The sky contrast was really quite good. And so we have M8, obviously the Lagoon Nebula on the right, and then the very pretty Trifid Nebula on the left with its combination of reflection, blue, and emission, pink-red nebulosity. And then a closer view of M8, the Lagoon Nebula, with various Barnard Dark Nebula in it as well. So yeah, interesting, but 4,000 light years distant, fairly almost next door to us actually. And then I will finish up with something that some of you will have seen. So exactly 1 year ago, there was no pandemic. There actually was flying around the world. And so this photograph will be familiar to those of you who see Sky News. This was the photograph that was a 2-page spread in the March edition of Sky News, and the photo that I got from Australia, super wide angle of the center of the Milky Way straight overhead, and something that we will never again see in our lifetimes. Jupiter here and Saturn down here, straddling on either side of the central bulge of our Milky Way galaxy. And I was quite fortuitous that I was down there at this time to be able to get it. And with that, I will simply thank you. And that concludes my presentation.
Thank you, Michael. Fantastic images, really, really nice, well done. Congrats on getting beautiful images. And also images of the comet. Those are really nice. And believe it or not, you are the first person showing comet images in our recreational astronomy night meetings.
Oh my goodness, wow.
Yeah.
There you go. People have been staying indoors.
Yeah, I haven't been able to get anybody else to show us their comet photos. I know a lot of taking photos. So thanks again.
You're
very good.
welcome.
So let's go to some questions from Ennio and the audience.
So we have 2 questions from Lewis Rifkin. The first question is, have you ever had any issues with bears? And the second question is, how often do you go out to shoot?
Okay, well, the first question, I haven't had issues with bears, but I've had a lot of encounters. I've had encounters with both Ursa Major and Ursa Minor. But wait a minute, I don't think that that's what you're talking about. No, I haven't. I do a lot of canoeing in Algonquin as well, and camping. And, I've seen fresh bear tracks. I hear wolves, don't see them. I hear a lot of moose. In around my observing area, there are a lot of moose that come. And so in the middle of the night or 3 in the morning, I'll hear grunting and snuffling, and I'll take my little headlight and go over, and I'll see a moose just looking up at me. And these are big animals. So no, the bears don't bother me. They're not up as late as I am. And sorry, the second question was?
How often do you go out to shoot?
I go out when it's clear, every new moon if I can. And if there's any possibility of it being clear, I will drive 285 kilometers, which is from our house in Midtown Toronto, up to Algonquin Park, set up, shoot, drive back to Toronto, and then go to work the next morning. At my age, I don't have that many years of astrophotography left, and some of you will know that this year in May I celebrated my 50th year as a member of the RASC. So I've been doing this a long time. That'll give you an idea how old I am.
From Gerardo we have, is there an app that will superimpose the lines, names, and stars on a photo?
Oh, that's a really good question, and I get that asked all the time. There may very well be, but I'm not aware of one. What I do, and I'll just explain this very quickly, so I know this may be the last question. Those of you who follow my stuff know that I use my favorite planetarium app is Dave Lane's Earth-Centered Universe. It doesn't have all the fancy graphics and so on, but what it has very precise constellation boundaries and so on. And what I can do is I can take screenshots of that and then in Photoshop superimpose them on top of the of my photograph, and then a sort of bend, contort, and transform it so that all of the stars exactly line up, and then I can trace the constellation boundaries and the exact outlines and boundaries of the deep sky object. So that's how I do it. Now, it takes a long time. If I'm doing one of these photographs, for example, of Cygnus, it'll take me 2 hours to do all of that work, but there isn't anything that I know that does it accurately and automatically.
And the last question is from Blake and Carol. What do you use for stacking?
I use Registar. I know that that is outmoded. I know that that the new Photoshop, which I use Photoshop CS6, which is the slightly older one. The new Photoshop will do that. I know that Alan Dyer, probably Canada's preeminent astrophotographer, uses Photoshop to do his stacking. I use Registar. It still works fine. I did a couple of photos today using Registar. It stacks, it registers the images very well. Then you crop them, save them, and then in Photoshop, I superimpose all of my images on top of each other, and that's what produces these photos.
And another question just came in from Riza Mohammed. Do you stack images with different ISOs?
Very good question. No, I don't. You probably can, but after I've taken some test photos, whenever I'm doing a new object, I'll take some test photos, very short exposures at very high ISOs to center the object to get exactly where I want. And then I reduce it down to the ISO that I want, where I can shoot for a 60-second exposure, take one, test one to make sure it works. And then I do anywhere between 6 and 20 identical exposures, identical in every respect, including ISO. I find that that produces the best stacked images. That better be it. I think I've more than used up my time.
That's all the questions we have currently on YouTube. Thank you.
Okay.
All right. Thanks again, Michael.
My pleasure.
Glad to have you, and I'll be in touch for another presentation in a few months. All right, so let's move on to our next speaker. Now, for those of us who joined us a little bit later after the initial introduction that I made, I mentioned that Wayne Parker had an urgent matter come up this evening, and he's unable to speak to us, and we'll try and reschedule him for the November meeting. So in his place, Claudio Oriani has gracefully volunteered to fill in that spot, and Claudio will talk to us about planetary image processing. So if Claudio, you're ready, over to you.
Hi guys, thank you Paul for having me tonight. Tonight I'm going to speak about planetary imaging, and specifically how to get from A, the video on the left, to B, the processed image on the right. And I will try to explain my recipe on how to get from A to B. So fasten your belts and let's get started. So first of all, what do you need to acquire planetary images? A telescope, a robust mount, a planetary camera, a laptop, an acquisition software, a stacking software, and image processing software. The good news is that planets are visible even in the light polluted areas, so you don't have to go to Algonquin Park to watch the planet to get beautiful images. A planetary camera is my choice. There's also other options. So for example, you can also try with the eyepiece projection with the DSLR camera. You remove the lens and you connect your body of the camera to the telescope. But this is my setup. So I have a Schmidt-Cassegrain telescope, is 8 inches Celestron 8, with a motorized equatorial mount, a power supply, and a dew shield. You will need a dew shield when you're outside for 3 hours, because otherwise your lenses will be not usable. And I'm using a planetary color astronomy camera, the ZWO ASI 224MC. I'm not endorsing any of the brands and models for the camera, telescope, software, and so on, just my setup. I also know that the mono camera are usually performing better, but you will have to combine videos taken with 3 different filters, red, green, and blue. And sometimes you don't have time to process all the images. And above all, the signal, the transparency will change during your capturing sessions. You also need a very capable laptop with space on your hard drive. An average 2 minutes video of Mars can be up to 6 gigabytes. And there are lots of free software. I'm personally using Firecapture to capture the videos, stacking with auto stackers, and image processing, Registax, and then GIMP. I'm also having a folding table, a camping chair, also a blanket that be very useful to be outside for 2 or 3 hours. A bonus, I'm also using an atmospheric dispersion corrector when objects are very low to the horizon, like Jupiter and Saturn in the next few years. You can help combining the different colors that are diffracted differently. So the red, the green, and the blue can be better processed by your camera. And I'm also using a vibration suppression pad to reduce the vibration of my mount when I'm playing with the focusing and so on. There are other acquisition software I'm also using combined with the Firecapture. There is SharpCap, and this is very useful because it's a useful focus assistant feature. Or also ASI Studio, but this last software is only working with the ZWO ASI cameras. Before starting your observation, and this is particularly true if you are working with the Schmidt-Cassegrain of a Newtonian telescope, acclimatize your telescope. You need to set up your telescope at least, let's say, 30 for 45 minutes. Otherwise, the temperature inside your telescope will not be balanced and your images will not be good. You also need a firm ground. For the most part of my time, I'm capturing images on my deck. This is not the best option, but as I say, the vibration suppression pad can help. And also when you try to focus, you're also moving your scope. And another important thing I want to highlight is that you have to align your telescope as much as you can. And also collimate if you have a Newtonian and a Schmidt-Cassegrain. There are lots of tutorials around, but you need to collimate almost before every session, I would say, to get the best from your telescope. And then you are ready to go. So my recipe, focusing. It's very important to reach the best focus you can. SharpCap has an interesting function called Focus Assistant. You may need to refocus your lens and your telescope during the session because the temperature will drop, the transparency can change, and so on. If you're using SharpCap, you have to use a contrast edge detection or contrast brightness range detection or Fourier detail detection. You have to reach the tall green bars to have high values. If you are there, you're good to go. Then you have to connect your planetary camera to the laptop through a 3.0 USB port. You get to transfer the images from your camera to your computer as fast as you can. And then finally, you can start your lucky imaging program. High-speed videos can effectively freeze some frames because we are in an atmosphere and this is moving the images. I would say that probably the best number of frames is 2000 frames or above, depending on your transparency condition. And also the histogram, as we are going to see shortly, must be around 70%. You have to balance between the exposure time and the gain. Not to use a too aggressive gain, because this will introduce background noise. It is a little bit difficult to remove post-processing. Basics of lucky imaging. First, you want to reach the long focal length. Usually f20 is a good number, but only when possible. Again, you have to check the transparency and you have to check the seeing before using your Barlow lens. Try to use a good Barlow lens or even a teleview. You have to mount you have to align your mount and tracking the sidereal, lunar, or whatever is the best for the target you are capturing. Focus, high-speed video, the formats are AVI or SER, and try to keep short exposure time to try to capture lucky frame. That's why the name is lucky imaging. Short exposure time is usually helping removing the movement of our atmosphere. And then you have to select the best frames from your video for stacking. My experience says that usually 20 to 30% is the maximum number of frames you can try to process. But let's go to the process. So first of all, I'm launching the video capture program, Fire Capture. Then I select and stack the best 20-30% frames with auto stacker. Adjust the wavelet to reveal lots of hidden data in image after they have been stacked with registacks. And then, if needed, final adjustments with GIMP. This is a good and free alternative to Photoshop. So I'm working with the levels, curves, sharpening, and noise. The good news is that all these software are free. With the Fire Capture or SharkCap, an interesting feature is that you have to reduce the area you want to capture. You want to capture just around the planet. You don't want to have too much black background because you're just increasing the size of your video without adding any information. So you want to use the region of interest, ROI. Try to change the exposure time and the gain to obtain values around 70% in the histogram. So increase the exposure time, reduce the gain, or vice versa. Select the auto-align function so that the software will take care of keeping the image in the center of your video. Capture at least 2000 frames at high speed, the maximum number of frames per second. I discovered after probably 1 year of capturing images that you don't need gamma or debayer. If you are enabled debayer, you will see your image in color, but you are not adding any information. You're just increasing the size of your video. So the debayer on is only useful when you are to try to focus your image. But then remember to check out this option. Then you have your video. You load your video, AFI or SER in AutoStacker. AutoStacker has just 3 steps. The first one, of course, you open your raw video. Then you select the planet as image stabilization, and the quality estimator, the default is 4. 4 to 5 are the numbers that are working best for me. Then you want to save your image in TIFF, and you want to select the number of frames you want to stack. This number can change after you analyze your video. Then you want to add your alignment points. This is depending on the size of your telescope and the size of your sensor on your camera. And what you're going to get is a quality graph.
Looks like we're having some technical difficulties at Claudio's site. Yeah, his internet is not responsive. Apparently, he may have crashed. Okay, so we lost our speaker. I guess his internet connection failed. Let's give him a moment to get back online. Okay, we'll go to fun facts. Be right back. All right, so we have Claudio back. I'll turn it over to him to continue his presentation.
Hi guys, sorry, I had some issues with my internet connection. Everybody home, obviously. And yes, I was talking about how to process with AutoStacker once you have your image. So you load your image, your video is AVI or SER video, and you just have this image on the right side of your AutoStacker. Then you have to create the alignment points, but first you have to analyze your image. So what they are going to do is to click the button Analyze and then wait until the software will show you a graph on the left side. Then you select the best frame, and finally, you can decide to place your alignment point grid. Click here and then decide how many frames you want to stack. And then you are ready to go. Click Stack button, and you are stacking your image. AutoStacker will work on its own. You wait patiently. And then finally, you have this image that you open with Registacks. It will be a little bit blurry, but it is normal at this point. Don't worry, because this is when the magic happens. At this point, you have to use Registacks to work on the wavelets, to sharpening your image. How? On the left side, you can change your configuration, and there are sliders, 6 different layers. In my experience, I'm not using the first layer because it's a little bit too aggressive. I'm starting using the second layer, the third, the fourth, the fifth, and there is no golden rule. Again, depends on the seeing or the transparency of this night. So what you're going to do is to play with these sliders. You can increase the sharpening, you can increase the denoise, and then finally you can play with the RGB alignment. And finally, you save your image. Don't forget to press Do All to see the result, and then save your image in TIFF. And then you're ready to go. With GIMP, or if you have Photoshop, it's fine. I'm usually working just to enhance a little bit of the colors and work on the curves. Then with the levels. And finally, I'm enhancing the sharpening. And finally, I have my image. There are different ways to capture your images. This is another option. I used to play with my DSLR camera and a telescope adapter. If you have a Canon, you have to order a Canon. If you're a Nikon, you have to order a Nikon T-Ring. You need the eyepiece of your telescope and the tele-extender for eyepiece projection. Important, your DSLR must have a programmable self-timer or remote shutter. Otherwise, the vibration you are inducing on your scope by just pressing the shutter release button will destroy your image. And you can also, of course, play with your smartphone. You can try to capture some images of the moon or the most brilliant planet with your smartphone, but you can process without a sucker. It's just, if you have a public outreach event, there are smartphone adapter. I'm using the Celestron XYZ universal smartphone adapter, and it's working very well on the moon. And this is some of my processed images you can find on Flickr. So this is Mars on September 21st. And you can see some interesting feature of Mars. So you can see Solis Lacus, the so-called eye of Mars. The second one, taken on October 3rd, the very prominent triangular dark area on the top of the area is Syrtis Major, and is an albedo feature. The bright area below is Hellas Planitia, an ancient crater impact. By the way, all these names were created by an Italian astronomer, Schiaparelli, in the 19th century, using fancy classical Latin names. And the latest image, just a couple of days ago, you can see the top bright area is a volcano, Elysium Mount, the 4th tallest volcano on Mars. It's a 12.7 kilometer tall. There are 2 dark forks below that are also visible, not far from the crater Gale, that is the landing site of the Mars rover Curiosity. Next, this is an image I'm very proud of. I was able to capture the 2 moons of Mars by using a fire capture plugin named Planetary Mask. I basically masked the bright disk of the planet. I increased the gain and the exposure time until the moons appeared on the video. And then, as usual, I processed the final video with auto-stackered Registacks again. Another thing before asking for a question, how I got to these results in a little bit more than 2 years. I started planetary imaging about 2 years ago, looking for other planetary imagers, and I would mention probably Damien Peach, Christopher Go, and recently also Dylan O'Donnell published a video about planetary imaging and just how to use fire capture. And that's it for me.
Fantastic. Thank you very much, Claudio. Beautiful images of Mars. And for a moment, I thought you were showing us a photo of a solar eclipse, but not so. Very interesting. I hadn't seen that ever before, occulting Mars to show the moons. Well done. Thanks again for stepping in and filling in the void this evening with your presentation. Let's go over to Ennio. Any questions?
Yeah, we have a question from Blake Nancaro. Why don't you use the stacking feature in Registacks?
That's a very good question. I found that for my camera, the ASI 224MC, fire capture is the software that is the best fit. I'm also trying to use the proprietary software provided by DWO, that is ASI Studio. But again, I found that the best results I'm getting are with fire capture. And by the way, fire capture has very interesting features. You can also auto-align, you can also connect your focuser to fire capture. You can use your electronic focuser directly with fire capture. So you don't have to move to the telescope and going back.
The question I have is, on your Flickr page, do you have any examples of images you've captured and processed using a mobile phone?
Not yet, but I will publish them soon, and I will also add some comments so that it will be available. By the way, I'd like to create my own website, astronomical website, but this requires time and dedication. So probably stay tuned, and in a few months, I hope to have a website when I'm explaining how I'm processing images.
Looking forward to that, Claudio.
Thank you very much.
Any more questions for him? Nothing else, Ennio?
No other questions right now.
Okay, very good. So we are done with our speakers for this evening. Thanks again to all three of our speakers. We are going to wrap up the evening with the usual announcements from our President, Ralph Chu. Ralph, are you there?
Yes, thank you. Good evening, everybody. I'll start by saying thank you again to Arnold, Michael, and Claudio for their presentations tonight. It's great to see the wonderful imaging that both Michael and Claudio have been able to produce and to demonstrate what they do to achieve them. Congratulations and thank you again. Okay, let's see what's coming up over the next couple of weeks. Our next meeting online will be a speaker's night. The question mark there was because up until the announcement that we were going back into a modified stage 2, one always hopes that we might be able to do face-to-face meetings again, but unfortunately not. So our next meeting on the 2 weeks from tonight, on Wednesday, the 28th of October, our speaker will be Dr. Camille Marsan, who is with the Department of Physics and Astronomy at York University. And she'll be talking about haunting monsters in an infant cosmos, investigating the greatest star factories in the universe. and that should be an interesting talk indeed. 2 weeks after that, we will have our next Recreational Astronomy Night presentation online. And, oh, sorry about that. Our program will start off with Dennis Gray presenting the sky this month. Hopefully we will have Wayne Parker doing his presentation on the SkyShed Pod Max. And then there will be maybe one open slot. But in any case, as Paul mentioned earlier, if you'd like to offer a presentation either for this meeting or for the December Recreational Astronomy Night online, please contact Paul and we'll be happy to see you share your stuff online. Okay, again, all of our education and public outreach activities are basically virtual star parties these days. We've had some successful presentations at the DDO and at the Ontario Science Centre over the last little while. And we will have another opportunity to do some education and public outreach on Halloween when the Science Centre does their Halloween star party. And that will go ahead despite the fact that the Science Centre is still closed to the public. They were planning to start restricted public hours on weekends starting this coming weekend, but unfortunately because of the stage 2 declaration, they will not be opening, and we're not sure when they're actually going to start receiving visitors to go into the displays. And similarly, that means that we're not going to have access to the Science Centre again for quite some time before we can actually have meetings there. Similarly, that means that all of our observing events are suspended as well, unless we can do some kind of virtual kind of gathering. So I'm afraid that if you want to do observing, you're on your own. We can't do anything as an organization at this time. I will remind you that in addition to our programs, the National Society has a wide variety of things going on, programs to learn how to use the Observer's Handbook. They do have a speaker series, and there's a variety of other things that they're offering online. So please make sure you visit the national website to see what is on offer. And of course, they have been sending out email messages to all members who have valid email addresses, advising you of the programs that they're offering over the coming week. So please watch for that and make sure that you are seeing those messages, that they're not going to junk. Unfortunately, because of the pandemic situation, we've had to reclose the CAO for the foreseeable future. So we're only doing maintenance activities on site right now. Those of you who are either leasing the pods or lockers on the site, you should be hearing from the CAO committee to let you know what the situation is regarding your stuff at the CAO and access to it. So again, please watch for that message to come in to you. And also we will be doing something about the rental and pass fees as well, to take into account the fact that we can't use the site at this time. It's really unfortunate that this has happened, because we had done a lot to prepare the site for people to use, and you know, with the stage 2 declaration here in the GTA, it's not advised that people from the GTA go up to other places like the CAO, and so we've decided that the safest thing to do is to shut down the site for now, and we will just wait to see what happens. Membership renewals, a lot of you will be receiving those notices because of the fact that October tends to be the renewal time for a lot of members due to the old membership system. But let me remind you that you can renew online at secure.rasc.ca, and we would appreciate it if you would renew promptly so that you don't lose contact and that you can continue accessing the members-only web pages on our website. If you are encountering some financial difficulties but would like to renew, there is an emergency fund that has received support from other members who are not in financial straits, and you can contact the membership person at the national office at this address, mempub@rasc.ca, to inquire about access to the emergency fund to help you with your membership renewals if you're in that situation. Again, we're trying to make sure that people can maintain their connections no matter what. We also are still looking for help to maintain the various activities that we can at this time. Blake is our volunteer coordinator, and he and his committee are working to orient volunteers and get them over to the various committees that need help. And again, if you can help out with certain things, we would certainly appreciate your assistance. One very important volunteer position that has now come open is editor of scope. After many, many years serving in that position as editor, Eric Briggs has basically informed us that he's unable to continue in the role. And so if you would like to help out with editing and writing and all of that, you can certainly get in touch with our volunteer committee to chat about that. And again, this is a really important function, and we'd really appreciate it if somebody could help us out with this. And that basically is it for now. Thank you very, very much for joining us this evening. We'll look forward to seeing you in a couple of weeks online. And in the meantime, enjoy the skies as they clear out. This is probably one of the best times of the year to do any observing. So again, clear skies to you. Stay healthy, stay safe, and we'll see you in a couple of weeks. Good night. Take care.